Okay, so good morning, friends. Let us start with second part of unit number 3, that is root locus, right? So before that, see, this session will be why we are learning root locus. Once we get why we are doing this, right, it will be easy and so interesting for us to cope up with this second part, right? And the thing is that you will have to keep patience for first two videos because it's like a you can say suspense movie, right? First of all we will see some parts, and after that we will join all the parts to have the root locus, right? So we have seen RH criteria, right? So how to check the stability? So we can check the stability, by RH criteria. But what was the problem, it will only what are the limitations of RH criteria? That exact location of the pole cannot be determined, right? We just know that whether all the poles are on the left hand side or on the right hand side, right? If it is on if a single pole is on right hand side, then what happens, the system is unstable, right? But if you want to exactly locate where the pole is, right, we cannot locate by using RH criteria. So this was one of the limitation of RH criteria. Then second is RH criteria is not applicable for complex coefficient of the characteristics equation, right? It is not working for complex coefficient. Then RH is applicable for finite number of terms, right? For finite number of terms we can apply this, like for example, if I will give the RH criteria to if I will give the characteristics equation having let us say the denominator polynomial of order 100, right? So it is not possible, or it is somewhat difficult, right? So that is one case. And then again next one is it cannot differentiate between real and complex poles. Okay, this is one more limitation. And also it is valid only if the characteristics equation is algebraic, right? Okay, so these are the limitations of RH criteria. So the major limitation is that we cannot find the exact what we can say location of the poles, right? So hence the second topic is there, that is your root locus. It is somewhat advanced version where what we can do, we can we get the location of the poles. Okay, now see, let us okay, there is some opening. Hello. Yeah, so the thing is that, yeah, so root locus, so what is locus? Let us say in maths, what is locus? Locus is nothing but collection of all the points is called as locus, right? For example, if I will give the example of, is circle a locus? Yes, circle is a locus, right? For example, what is circle? Circle is nothing but locus of point which is equidistant from the given point, and that point is called as center. So that is called as your circle. Similarly, parabola is your locus, hyperbola is locus, ellipse is locus. So what is locus? Locus is nothing but collection of all the points. So root locus means what? Root locus is nothing but the collection of all the roots, right? And which roots we are interested in? Numerator polynomial or denominator polynomial. So we are always interested in the roots of the characteristics equation, which we get from the denominator of the closed loop transfer function. Okay, so what is root locus? Root locus is nothing but we can say it is collection of all the poles. Okay, so first of all, there are a lot of points, right? At least 9 or 10 points are there. So we need to understand each and every point, and when we will have a clear idea regarding that 10 points, we can plot this diagram, right? So it is like a curve tracing. Okay, we need to trace the curve, and we can find the stability of the system. So let us start with directly root locus, right? So we know this is your closed loop transfer function is g of h upon 1 plus g of s into h of s, right? Now what is the characteristics equation? It is nothing but 1 plus this denominator is equal to 0, equate denominator is equal to 0. So this is your characteristics equation. So it is 1 plus g into h is equal to 0. So this is your characteristics equation. For example, g of s is given k by s, right? H of s is given 1, means unity feedback system. So what is your characteristics equation? G upon 1 plus gh, and its denominator will be 1 plus if you compare with this, 1 plus g into h, so it will be 1 plus k by s into 1, and then you just equate it to 0. So s into 1 s plus k is equal to s into 0. So this characteristics equation is s plus k is equal to 0. So like this, if you know g of s, if you know h of s, you can happily find the characteristics equation. Okay, and now see the here the characteristics, what is the k? K is nothing but your constant. Okay, now see here characteristics equation depends on value of k. Okay, now root of the characteristics equation depends on k, is it? Yes, because characteristics equation is s plus k, and therefore one it is your first order system. So what is the root of this characteristics equation? S is equal to minus k. So s is equal to minus k means was it means what? S depends on k, right? So means if s is depending on k, if k increases, right, s also decreases, and if k decreases, s increases, because s is equal to minus k we can write. So we can say if I vary the value of k from minus infinity to plus infinity, right, your value of s will also vary accordingly. Okay, so yeah, so means what? If all locations are joint, resulting in the diagram of root locus, means what? See here from this equation, let us keep it simple. From this equation I can write s is equal to minus k. Okay, so s is equal to minus k means what? K increases, s decreases, right? And if k decreases, s increases, right? K decreases, s increases, and k increases, s decreases, right? So we know k, s completely depends on s completely depends on k. Now what is root locus? Root locus is nothing but, yes, the locus of all the points of this roots. Roots are nothing but, let us say, value of k. So k varies from minus infinity to plus infinity, and s varies from plus infinity to minus infinity. And if I join all the values of s by varying k, right, whatever diagram I will get, that will be called as root locus diagram, right? Now let us hold on, I will explain all these points as we go further in the lecture, right? Now what is root locus? So we can say root locus is a plot of locus of closed loop poles, right, as function of open loop gain k when k is varied from 0 to infinity. Right, now what is this? This is, again we will explain. So a plot of closed loop poles. So what are closed loop poles? S plus k is equal to 0, so s is equal to minus k. This was one closed loop pole. So what we need to do? We need to plot the graph of s, right, when k is varying. And from where we need to vary the k? We need to vary the k from, yes, 0 to infinity only, right? Because when k is varied from 0 to infinity, s will be varied from 0 to minus infinity, because s is equal to minus of k. Okay, so k अगर 0 to infinity रहेगा, तो s का वैल्यू ऑब्वियसली इट विल बी फ्रॉम 0 टू माइनस इन्फिनिटी, निगेटिव साइड में. एंड अगर लॉजिकली देखना है अपने को, तो लॉजिकली हमें s जो है, मतलब पोल्स कहाँ पर चाहिए? लेफ्ट हैंड साइड में चाहिए या राइट हैंड साइड में चाहिए? ऑब्वियसली वी वांट ऑन द लेफ्ट हैंड साइड. सो लेफ्ट हैंड साइड में चाहिए, मतलब क्या? लेफ्ट हैंड साइड में व्हाट इज द रेंज ऑफ x-axis? It is from 0 to minus infinity. Okay, so again I will say the same thing. Whenever we will proceed in this chapter, you will get all these ideas clearly. Okay, then there are two types of root locus, right? One is your direct root locus and another is indirect root locus, right? So direct root locus means what? K varies from 0 to infinity. Indirectly it will be exactly ulta. We are varying k from minus infinity to 0. Okay, so let us have one question let us have the question, find the unity okay, for the unity feedback with g of s is equal to k by s, obtain the root locus. We need to draw the value of root locus, right? We need to draw the diagram of root locus. So for unity feedback means what? Can we calculate the closed loop transfer function? Of course we can calculate the closed loop transfer function, and from that closed loop transfer function we know the denominator is 1 upon 1 plus k by s is equal to 0, as explained earlier. So therefore s plus k is equal to 0. So from here I can write s is equal to minus k. Now can you draw the diagram? Yes, obviously. See, this is your real axis, this is your imaginary axis. When k is equal to 0, s is obviously equal to 0. When k is equal to infinity, s will be equal to minus infinity. So just vary the value of k, right, and you will get the range of s. What is s? S is from 0 to minus infinity. So 0 to minus infinity, can you plot the diagram? Can you plot the points 0 to minus infinity? So all the negative axis, I am shading this, right? This is thicker, negative x-axis is thicker. So this this shaded or this bold line this bold negative axis, x-axis, represents the root locus. So for this characteristics function s plus k is equal to 0, the root locus is this, right? That is from 0 k is equal to 0, right? Sorry, from s is equal to 0 to s is equal to minus infinity. So this is, you can say, the range of s, okay, and this is your root locus. Okay, now again I am saying that what I will be doing, I will take each part, I will solve a small question on that, and then you just what is your job? Your job is to understand only one question, and then we will compile all the questions together, and then we can solve a big problem, right? That problem may be for 10 marks in your exam, so concentrate